Welcome to Academic Digest class. Today we are treating mechanical energy, and I need you to know that when you hear mechanical, it deals with related to motion, or you say it deals with motion. And in mechanical energy, we have the kinetic energy and the potential energy. We represent it with PE and KE. So there's a question that is before us. The question says, state the law of conservation of mechanical energy. So the law of conservation of mechanical energy states that energy in a closed system, I say energy, it states that energy can neither be created nor destroyed, but can be transferred or transformed from one form to the other. And the formula for this law or this principle is simply potential energy plus kinetic energy is equals to 0, or you say it's equals to constant, is steady, is constant. So some textbook you see it equals to 0. So whichever way, you know that when they say it's equals to 0, it means it's equals to a constant. That is held constant. The total system is 0, is at equilibrium. So you need to know this. That is why when a car and then another car hits, you hear sound. So they convert movement to sound. So there are different cases. Different cases like when you have your, let's say, your bell hits, the bell bulb hits should I say the walls of the bell, or you say the parts of the bell, you notice that it produces sound. So whenever you are dealing with motion, in most cases, it is usually transferred from mechanical to sound. And you have cases where it can transform from mechanical to heat. So, but what I want us to treat today is looking deep into this mechanical energy, because I've seen that sometimes the questions get asked under this and some students don't know how to go about it. All right, let's say I have a board. You notice that the formula for this is mgh, and formula for this is half mv squared. Check our previous video, we've derived this. So notice that there's always heights when we are talking about potential energy, and this height is the same thing as displacement. So a situation whereby it is not vertical and maybe it's moving in such a way, we can consider it to be S there. So let's say I have a stone, and this stone is dropped from a height. These are two cases. So case 1, that's what we are looking at, case 1. So at the point where this stone is, before it was dropped, it has potential energy. Now when it reaches the ground, it covers a distance, and that distance it covers is through motion. It will go through motion to get it. So at that point you have kinetic energy when it gets down. So if I ask you what is the mechanical energy of the system, you simply tell me that potential energy is equals to kinetic energy. So notice that this is complete motion. It has completed the motion. It moved from up, hits down. If a car moves from this point, then come here and park, the total mechanical energy is simply PE is equals to KE. That is the potential energy, the tendency of the body moving, and the motion that it's covered. But if, for example, case 2, If, for example, I have a body, a stone, for example, is dropped, and this stone want to hit the ground, but before hitting the ground, let's say halfway, or at any point, but before it hits the ground, at any point here, they ask me what is the mechanical energy, for example, at this point, or at this point, or at this point, or at this point. So any of them that they ask me, notice that the motion is not complete. So if they are asking me at this point, that means that at this point I have to come to a stop and check what is happening there. So remember that when it's at rest, when it's moving from rest, is PE. That is the tendency of the body to attend motion. That is the ease ability. But it's not moving. Now, at this point, if they tell me to find this point, it has PE. It will have PE because I will come and, as I'm checking the kinetic energy here, is moving. So I have to keep it at a stop. So you see that I'm having both kinetic energy and potential energy at any of these points that I want to check the mechanical energy. So I will have to notice that there will be a stop, because when a body is moving, for example, if he has not gotten to the finish line, to the finish line, it still has tendency to come down. Are you seeing it? So at this point, if you are checking potential energy, if you are checking the mechanical energy of this at any of these points, it has the ability to still come down. It has the ability. So that is why you will simply say that in this case, the mechanical energy of a body in motion, that is still in motion, is going to be potential energy equals to kinetic energy plus potential energy. So it has not gotten to the final points. So any point you are checking it here, it still has that tendency to keep moving. Then it is in motion as well. Kinetic energy will be there. So kinetic energy plus, kinetic energy plus, kinetic energy plus. And remember that kinetic energy is what it starts, potential energy is what it starts with, that at that point of tendency. So you see that in this case where it moves from up or from any point and gets to the finish line, we say potential energy is equals to the kinetic energy, because there is no movement again, there is no tendency for it to move again. It has come to the resting place. In as much as it is resting, we know that yes, it still has the tendency to move, and that is why this is equals to this. But when I come at any point and I'm checking what is the mechanical energy or checking anything, I have to take note that even as it's here, that it still has that potential energy and is in motion, which is Ke. So I will note that. So for that reason, these are the two cases I want you to take note of whenever you are dealing with mechanical energy questions. So body that is still in motion, so mechanical energy of body that is still in motion, that is this case. So this one is mechanical energy of body that has completed motion. All right, I don't know, this completed should not confuse you, but I just believe that if you use the example how I've illustrated it, it's something that you just have to think, and you get used to the insights, the knowledge there. Some of these things are little things that there's a way you have to be thinking about it. It flash and it sticks there once you know it. All right, let's go back and look at questions. So we have a question here. The first question says, we've stated the principle of conservation already. First question says, a pendulum bulb is suspended by a thread of length 100 centimeter. Look at the pendulum bulb here. Now they are asking the suspended length, and the bulb is put aside until the string makes an angle of 60 degrees with the vertical. It is then released. Calculate the velocity of the bulb when the string is vertical. All right, so notice that, see what they are saying. They said we pull, you know, pendulum bob now, we have the length, then they come and tie it, tie it. Then let's say this is the pendulum bob here, they come and pull it. So when they pull it now, as they pull it, it moves such that this thing that you're seeing as height, it doesn't mean that it is at this point. So at the point when they pull it, the pendulum bob is more like this now. So notice that this is the part where it's hanging. So when they pull it now, the bulb is like somewhere here. So when it rotates again, it will come this way. So you see that at this point, you have potential energy. At this point where it's come like this, they pulled it to make this angle 60 degrees. So when they release it, it will come to a point where it will meet that vertical. So they're asking us at the point of vertical, what is the velocity at the point of this vertical? So when this thing move and come to this point of vertical, notice that it has completed its motion here. Then it will go back again. Then come back again, complete motion. And you remember, that's what oscillation is. Those are our frequency time. So it will move from here. At the point where it's here, it's at a stop. It's not moving. It goes here, come, complete it. And I told you that whenever you complete motion, you simply say PE is equals to KE. So this is the formula we use for this. So and we know that we know that PE is equals to mgh. And K is half mv square. All right, so let's check our mass there. Did they give us mass? The pendulum bob is suspended. Okay, they did not give us mass, but we can cuckoo check and see that m is here, m is here, m cancel m. All right, g, let's take g to be 10. Did they give us height? Let's check. So notice that the total height will be this 100 centimeter. And notice that it started from somewhere here. That time that they pulled it, it went up a bit. So it formed something like a triangle. So we can say that the height will be this part minus this part. And what is here is x. So we can say the height is equals to 100 minus x. And what is x? X is equals to, if you check this right here, this is like a triangle. X here is on the adjacent part. And when we are dealing with adjacent, it's cos theta. So cos theta will be equals to adjacent over hypo. And the adjacent here is x. Then the hypotenuse. The hypotenuse now, I don't know it. Look here, you see that this is the hypotenuse part. I don't know it. So let's say hypotenuse. Then cos theta, the theta there is 60 degrees. So 60. Okay, wait. I think from the question, they gave us, yes, from the diagram, they gave us that, yes, okay, they gave us that this part is 100 cm. Somebody wants to ask me, how come? How is it 100? It's 100 because you can see that the total vertical length, see, if you remember when we did height of work done, for work done, what we have here is always what we have on this part. So that is for displacements. So I have that the hypotenuse is 100, so I have cos 60 degrees is equals to x over 100. And 100 cm, I want to take 100 cm to meter. So 100 cm is the same thing as saying 100 divided by 1000. Wait. No, 100 cm to meter. Remember, we have meter, decimeter, centimeter, millimeter. This way, multiply. Okay. If I'm going this way, I divide. See? 100 millimeter is 10 centimeter. So 100 centimeter should be 1. So should be 1. So this is something that's saying 100 divided by 100. So 1 times 100. So 1 meter. 1 meter. So all over 1. Cross multiply. You get x is equals to 1 cos 60. And cos 60 is what? Let's find out. And cos 60 is 0.5, which is equals to half. Okay, so which means that we can go back here and say that this is the sentence saying 10 times half and 1 5. So 5 equals to half v square. V square. So, and we know that we can cross multiply because this is the sentence saying 1 over 2 v square. So all over 1 cross multiply. So we have 5 times 2, 10 equals to v square. So that this becomes, take the square root of both sides. So that this cancels this. So that v is equals to 10, root 10. So root 10. And when we take root 10, let's punch it. Okay, when you punch root 10 on your calculator, it gives you v is equals to 3.16 meter per second. So that's root 10. Okay, for those of you that don't understand how this 100 came to be, remember that they said in the question that is suspended, pendulum bob is suspended by a thread length 100 cm. So this thing you are seeing here that forms this angle is the thread. So when you push this thread to this side, you see that it will go up that 100 meter because it's at an angle. It will go up to a point that it will shorten whenever something is at an angle. So it will go up. Then when it comes this way, you see that it will come straight to give you that 100. So at this point, this is the 100. So 100 cm. If you try it, you carry your, see this pen now. See it. See this pen. I see it straight. You see how straight it is. When you take it this way, you see it. So it's still the same thread. So at this point, where the mouth is this 0, this part. So you see it. Are you seeing it? So that is how that 100 came to be. So the next question we have is a body of mass 2 kg is released from a height 20 meter. Calculate its velocity at the ground. So its velocity at the ground, that means at the ground, it means that PE will be equals to KE. So you solve that one for me. Now, the one I want to solve is, they said also, and when it is 10 meters from the ground, when it is 10 meters from the ground, it has not completed the motion. It has not completed the motion. So when it's 10 meters from ground, it simply says that it's still going to have the tendency to reach the ground. So it will have PE and KE. And then remember that before it started, it had potential energy. So at that point, you will have potential energy. See the one we are solving when it is 10 meters from the ground. So it will have PE equals to KE plus PE. So solve for me this one when it hits the ground. So when it's 10 meters above the ground, at that point it still has potential to reach the ground and is in motion. Then before it started is PE. So this is going to be mgh equals to half mv square plus mgh. This can, in fact, everything here. Okay, but it's plus. Let me not go that way. Let me not go that way. So let's solve and see what we have. So remember they said a body of mass 2 kg is released from height. So it's 20 here. 20. When it's from that height, at that height, this is times 10. The g, I'm taking the g to be 10. So mass is 2 times 10 times 20 equals to half the mass. I have that is the sentence saying potential energy above the ground is equals to, before it started, is equals to half mv square plus mgh. And we know that this is also mgh. So here is going to be 2 times 10 times 20 is equals to half 2 times v square plus 2 times 10 times 10 above the ground. So this is going to be the same thing as saying 10 times 10, 100, 200, 200, yeah, yes. So plus this can take care of this. So I have v square plus v square equals to, so I have 10 times 20 is 200 times 2, 400 equals to 400. So I now have v square subject of the formula. We have 200 crossing over 400 minus 200 equals to v square. So v square is equals to 200. So take square root of both sides. So v is equals to root 200, which is the same thing as saying okay, let's do it this way. 10 times 2. Should yes. So what are you doing? 10 times 20. Should so 10 times 20. Yes. So, and notice that this can be the same thing as saying 10 times 10 is 100. This can be the same thing as saying v is equals to, it's also the same thing as saying 10 times 10 times 2. So this is the same thing as saying v is equals to root 100 times 2. So v, and I know that root 100 is 10. V is equals to 10. Okay, times 10. Okay, let's use it this way. Root 100 times root 2. So v is equals to 10 root 2. V is equals to, you can do root 2 times 100. So v is equals to 141.42. So v is approximately 141 meter per second. So this is the correct answer. This is what you should have. So PE, I was rushing that one. So you need to notice it. If the body is still in motion, before it starts, it has potential energy. At any point when it has not completed it, it still has the tendency to move. That is to hit the ground. Then there is a motion. So you need to know that. But if a body has completed motion, you simply say PE is equals to that kinetic energy. So these are the two cases you need to note. All right, let's look at the last part of that question. Let's look at the last part. Here's the last part. It says, if the body penetrates a distance of 1/4 meter, calculate, the body penetrates a distance of 1/4 meter, calculate the average resistance force. Calculate the average resistance force. Okay. And we know that resistance force talks about friction. Am I right? I should. Okay. So I need to remember that distance. So let's do it here. I will say this distance is the same thing as displacement 1/4 meter. So they said if the body penetrates a distance of 1/4. Calculate the average resistance force exerted by the sand. So I'll simply remember that anytime you are asked to find force in a situation where you have velocity and everything, what you just need to do is to remember that work is also equals to kinetic energy. And work is equals to Fs equals to half mv square. So I'll simply say F times 1/4 equals to half times 2 times the velocity. Okay, they say if the body penetrates 1/4 meter, calculate the average resistance force. So, and the velocity there when it hits the ground, it's the one we've gotten. Have we gotten it at the ground? Centimeter. Right. So let's check if we've gotten the velocity. Where is that we solve this? So we got it to be 400. Let's be sure. Yes. Remember from the heights, when we did from the heights, mg h. When we did from the heights, so we got okay, let's check, let's be sure. When we did half mv square, so I said let me find our v. Remember that mgh is equals to half mv square. So at the point where it hits the ground to penetrate the sand, it will have potential energy equals to kinetic energy. So it will have mv square, half mv square equals to mgh. So we know that m and m will cancel, so we get gh. Then that is 10 times 20, that is that height. 20, which is 200. 200. So if these two cross over, it becomes 400. So v square is equals to 400. And this is v square that we want to replace. So v square is equals to 400. It's different from v. V is equals to 20. V square is equals to, Shebi? Yes. Yes. So v square is equals to 400. So we can now try to solve everything so that we get 800 times 1/2 is equals to f times 1/4. This will cancel 2 here 1, 2 here 400. So we have f times 1/4 is equals to 400. F times 1/4. F over 4 equals to 400. You can see that cross multiply, F will be equals to 400 times 4. 400 times 4. F is equals to 1600 Newton. Now, how did I know that this is how to go about it? Remember that the question gave me, let's look at the question while talking about it. So the question gave me a body of mass 2 kg released from a height. So it gave me m and h, and I know that g is always constant. Here is 10, we are using it as mgh. They asked me to calculate the velocity at the ground. So it simply means that this is a question of energy, because If they give me this and they're telling me at the point where it's ground and at the point where it's 10 meters from the ground, so I know all those things. So they're not asking me to calculate it. So in most cases, when they give you this question, they will tell you using energy and work form that you should solve for it, because most times most students confuse it with kinematics. They just try to start using formula for kinematics to solve. So when the question is given, pay attention to certain things. So remember to subscribe. God bless you.